Hey guys, welcome back to our last video for lesson 17 where we're looking at double integrals in non-rectangular regions. And so the problem today is saying let's set up this region of S of xy dA where S is in the picture region right here. So one of the things that you should always think about is figuring out whether we want to do dx dy or dy dx. So if we want to go the traditional route, which again is our type 1 region where everything is going to be looking like this, our rectangles are going to be vertical, we come up with a really big problem. So remembering what is ideal is that the top of all of our rectangles and the bottom of our rectangles are always the same function. So why this is probably not the best option is that if you look at the region here, right, just this region right here, the top is always our line. That's awesome. But the bottom of our region, these rectangles are here, is going to be this curve. However, when we shift just a little bit, now look, our bottom has changed to this function. So that means that we would have to set up a second integral. Well, what makes things even worse is that then when you shift over here, we have the same function again. So we have to do two different integrals for this. So three total, right? So we have the curve, the line, and the curve again. So that's not looking so ideal for us. We probably want to think, well, what else can we do? Well, maybe we can go in the other direction. So we're going to go ahead and look at, well, will it be better to do it the other way? Well, if we start looking at rectangles in this way, so far so good. The left-hand curve is over here and the right-hand curve is here. However, when we get to down here, you can see that the right hand is actually going to be this curve. So regardless of what we do, we're going to have to set up at least two integrals. Well, in the case that you see right here, this is actually more ideal because we only have to do two. We have to do this region in the top and the region in the bottom. So I'm going to draw myself a little line like here. And so now the top of this is always going to have, this is our left curve and this is our right curve, and the bottom, the same curve is going to be the left and to the right. So what I'm going to do is I'm going to call this region 1 and I'm going to call this region 2. So we're going to set things up like this. Since our rectangles are in a horizontal fashion, we're going to do our relation of dx dy. So we're going to have a type 2 integration. So what I'm going to do now is I'm going to write down our region 1, and we're going to start out with this. So remember, these are going to be where y is equal to our numbers. So it's going to be our lower bound and our upper bound, all right? So with that, you can see that this is going to be y equals 1. Another way you could solve this, if you needed to, is just set the two functions equal to each other, and solve. And again, to save a little bit of time here, you will get that y is equal to 1, right? 2 minus 1 is the same thing as the square root of y. Or you could set negative x plus 2 equal to x squared, factor it out, get that x is equal to 1, and then also found that y is also equal to 1. So that means our lower bound is actually going to be 1 for this region, and our upper bound is going to be right here, which is going to be at y equals 4. So remember, that's the first thing you do is the constants are on the outside. Then we're going to look at the equation. So this is going to be x is equal to the equations. So since we're doing this in a region 2, it's always going to be the right curve minus our left curve. So that's how you learn it back in ABBC. Well, that means that the right curve is going to be the upper bound and the left curve is going to be the lower bound, right? So the lower bound. Okay, so in that case here, well, what is this? Well, that's why you guys can see that I've already drawn or rewrote, sorry, these equations in terms of x. So our right curve here is going to be 2 minus y. So that means that our upper bound in region 1 is going to be 2 minus y. That means that all the right-hand side is always going to be this equation right here. And the left-hand bound is going to be the curve of the square root of x. However, we want to be careful here. It's actually the negative, right? So this is the negative part of it. So you want to be very careful about this. So we want to make sure we put the negative part of that in here, okay? Because the left-hand curve is actually equal to x equals negative square root of y, because the positive square root of y is going to be over here, which we'll get to in a second. And so we go ahead and just write down the rest of our function, which is going to be xy. Oh, sorry, guys. My tablet is not doing so well. So, there's a little bit of drag on it today. X, Y, and again, we went dx, because again, we start with the x's, and then we have a dy. And so that's going to be our very first region. And we're going to do plus, I'm going to write it down here now, our region number 2. And we're going to do, again, in terms of dx and dy. Same story, and here is our region number 2. So what we're going to do again is look at our bounds. So this again is our y equals number. So it's going to be our lower y value and our higher y value. Well, you can see that our lower y value is right here at y equals 1/2. So I'm going to go ahead and do 1/2. So lower bound, and we're back up here to our top bound in this case, which is going to be 1. And now this is where we'll be very careful with it. So our right curve in this particular example is going to be this curve right here, right? Well, remember that curve is x equals the positive square root of y. So we're going to go ahead and do the positive square root of y here, and the left-hand curve is going to be the negative square root of y. Right? And that's a really bad way of drawing that. So let me just really quickly write that again. Just again, it was a little bit of a drag. So let me put that in us a little bit better. And there you go. So this is one of those examples where we are forced to actually set this up into multiple integrals. And our best solution here is to actually do it in 2 of them and do them in terms of x, y. All right. So that's where this video ends. This is where the lesson ends. I hope you guys are able to understand this, and we will talk later. So have a good rest of your day.